Okay, so simple interest. Oh, and apologies about the notes. I tried to sync it at home yesterday, and then SkyDrive kept telling me there's an issue with syncing up. They said try tomorrow. Anyway, so it should be up tonight. All this stuff as well as today's. So simple interest, we talked about yesterday, is based on the initial amount you invest in the bank. Right? And it's always worked out using that same amount. So if you put $1,000 in, every time after that, whatever your account says, simple interest is worked out based on that $1,000. Okay, with percentage and everything else. So interest is the same each year. You can divide it equally between months. It will always stay the same. So basically, the reason it's in this course, let me just make it clear, simple interest is not used really, except in the most simplest of cases in the real world, as far as I can know. The reason it's used is that it's like a lead-in to other types of interest. Okay, so it's giving you an idea, okay, what are we talking about when we say interest, introducing the concept, all these sort of things, and then we say, all right, now here's the proper way of working it out, which is compound interest, which is what we're going to look at today as well. So basically, simple interest, like I said, worked out the same amount each year. We'll go look at the formula later for it, but for the moment we're not going to just introduce the formula. Hopefully you can just work it out. So if $5,000 is in the bank at 6% per annum for 5 years, how much interest do they earn? How much money is in the bank after 5 years? Right, so we just need to work out, well, how much interest do they receive each year, and then you multiply it by how many years there are. So what we need to do is do 6% of 5,000. Okay, we need to work out 6%, 6 over 100, multiplied by 5,000. That is equal to 300. So $300. Right, and then you get that same amount. Doesn't matter if your account changes, you get that same amount each year. So we have to do 300 times 5. So that is equal to $1,500. Alright, so that's it. Just working out the interest per year, and then you say, well, if you have 5 years worth, how much do I get? So it's $1,500, and then how much is in the bank after 5 years? So you can do second part. It's 5,000 plus 1,500, and that's equal to $6,500 you'd have in the bank. Alright? We just align this. So 6,500 after 5 years at that simple interest rate. Next one, $23,000 is in a bank account. Interest is paid, and I should say to specify it's simple interest. Simple interest is paid at 7.5%, 7.5% per annum for 10 years. What is the investment worth after 10 years? It's the same process. Find what 7.5%, which I'll use a different method for this one. So we'll think about 7.5% of 23,000. So that is equal to, somebody tell me please, 1,725, thank you. Okay, so that's the interest for 10 years. 10 years of interest is equal to this times 10, which equals 17,250. Alright, so we're not doing too bad. So then what we end up with, the total is, yes, so it's 23,000 plus 17,250. Which equals 40,250. Okay, $40,250. which seems okay, but if it was compounded, even annually, it would be much more. Okay, when the compound interest builds up much quicker. But that's simple interest. So exercise 3.11, I'd like you to do for, let's say, 10 or 15 minutes. And then I'm going to go through the compound interest. Which at this stage, we're not going to do the formula. We're just going to introduce it, and then the formula comes in later on. Okay. So the idea of compound interest, so again, it's interest, so it's paid into your account. And you can take your headphones out, please. Headphones out, listening here. So compound interest is paid into your account, but obviously as it's paid into your account, we're assuming at the moment that we're not putting any more money in. If you just have a lump sum in your account and then interest is paid in, compound interest pays the interest in. And then the next time interest is paid, it's calculated on the new amount. Alright, so you have the amount, interest goes in, new amount, work out interest based on that, etc. And then that continues month after month or year after year, and so the amount is going to build and increase. It actually increases exponentially, so the longer it's in there, each time there'll be more interest each time, because the amount that you're basing it on is getting bigger. Okay, so that's the idea of compound. It's compounded. It's increased. It's added onto over and over again. Alright, so for this reason, you need to work out each year separately. Okay, there's a formula for this, but the formula does what we're about to do in a way that we just need to understand what's sort of going on, which will be helpful. So what we're doing is you work out the interest for that year, add it on, and then work out the interest for the new year with the new amount. So I'll show you a couple of methods to do this with. So let's just have a look. Alex has $1,500 in the bank at 5% per annum. How much is in the bank after 3 years? Okay? So we've got after 3 years. So what we need to do is take it year by year. So I'm going to do first year. So there's a couple of ways you can do it. So let me show you. First thing, we can work out 5%. This is the long way for this. 5% of 1,500 equals 75, I think it is. So $75. And then you have to do 1,500 plus 75. So at the end of the first year, you have $1,575. That's your first year. $1,575 at the end of that. The second way you can do it is add 5% onto 100%, so 105 over 100 times 1,500, which equals 1,575. Right, that's quite a good way, because then you can do it over and over again. So then the second year, this is where it's important, we then take this amount, the 1,575, and use it for our calculations. So 5 over 100 times 1,575 equals what? What's 5% of 1,575? $78.75, and then you add that on times 78.75. That equals to 1653.75. All right. Is that correct? That's not my answer to questions. Okay, so the other way, I'll do the other way for the third year. So we just alright, and then the third year. The third year we take this amount. So we do, and I'll do it the other way, 105 over 100 times 1653.75 equals what? Tell me what it is. 1.05 or 1.05 44. Okay. You can actually also do 1.05 times 1653.7. Okay, it's the same. So that's how much is in the bank after 3 years. After the first year, it's this much. Second year, 30. So you just, what you're doing, you can't do it all at once. You have to take a new amount and do it again and do it again. Okay? Any questions? Yes. Yeah? All right. Yeah. Yeah. Yeah, so you can actually do it over and over. If you get your calculator out, you just not text me class. Next time I'll take it. I'll tell you again, I'll take it. Okay. If you have the quick way to do this on your calculator is this. You put in 1500, if you times it by 1.05, and then press equals, it will come up. You multiply that by 1.05, you get answer times 1.05. Every time you press equals, it's the next year's amount. See how it's building up? Okay, so you're doing each answer, you're multiplying it by 1.05, so it's increasing and increasing. Okay, that's a quick way to do it. But you need to know the technique actually what you're doing. So I'll do the second example real quick. And I'll come back to this. Over 100,000 years. You haven't pressed the 100. Over 100,000 years, you would have like billions of dollars. So probably so much income. Okay, $20,000 is invested for 15 years at 7.5% per annum. What is the value of the investment after 2 years? So the quickest way to do this is 7.5. So I said, well, 20,000 times 1.075 equals, because this one is 100% plus 7.5%.
Can we do it the other way if that's way?
Yes, you can do it the other way, that's fine. Do whichever way you want, I'll just say this. If you're comfortable with this way is quick. So what's the answer to this?
We're trying to work it out.
2,276. 21,500.
What is it? Oh, can you just tell me what it is, please? 21,500 and anything else? No, that's it. Then the second one is 21,500 times 1.075. And that is equal to, Josh, find out for me.
So that number 15,000
23,000. So this 50. So in this context, no, it's 15 years doesn't make any difference. Yeah. All right. So that's compound interest. You can work on it. The formula will come later, but for the moment, we're just doing that manually.